Hello dear students, in the last video of this particular series I have discussed why we really need a binary number system, and we have clearly understood that computers don't understand the human language, and that is why to interact with a computer, so whenever we have a computer, if you want to interact with the computer, we need to have a different kind of language which is totally different from that of human. So humans are basically using the decimal number system, and computer use the binary numbers. They understand the binary number system. So whenever we are giving some input to the computer, that has to be converted into the binary, then only the computer will understand. At the same time, but this is about the input, but when we are talking about the output again, so whenever we give it input to a computer, we also expect some output from the computer. So when the computer is going to interact with the human, then again it will give out data in terms of, or give up the information in terms of binary codes only, so but which is not at all understandable by the humans. So in that case also, whenever this binary to decimal conversion has to be done. So whenever this happens, so here we are converting decimal to binary, and when we are trying to get an output from the computer from the human side, then we need a binary to decimal, because we don't understand exactly what is how a binary number system represents the things that we really want out of the computer. So now that is why from this we have understood that there is a need to understand how this binary, how this decimal to binary conversion happens. And in the second stage, so here we need decimal to binary conversion, and in the second stage we need to know how the binary to decimal conversion is happening. So in the second stage we will understand how binary to decimal conversion is happening. Okay, so this is a very easy method. We need just some kind of practice to master it. So let us start with that. So I will first start with the decimal to binary conversion method. So again I would like to repeat that the binary number system is according to digital electronics, so it is basically a binary system which uses only two numerical values, that is 0 and 1. Okay, and binary system is applied internally by almost all the latest computers and computer based devices, and because of its direct implementation in electronic circuits using logic gates, every digit is actually represented by a bit. This bit is nothing but a unit of memory used by the computer, so that is called concept of memory, which we will discuss in the videos that I will upload later. So whatever digit we are using here, whether it is 0 or 1, every digit is represented by a bit. So what is a bit and what are the larger units of memory of a computer, that we will study in towards the end of this particular chapter. So let us start with the conversion formula. So yes, so let us start with decimal to binary. So we will start with a very simple problem. So whenever we call decimal number, it can be anything: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it can be anything out of this 10 digits, or it can be any combination of this 10 digit. It can be a single digit, double digit, it can be triple digit, anything. So let us start with a single digit decimal number, say 4. So whenever I write, it simply means that it is a decimal number. So we need to convert it into the binary. Okay, this is our task. So how to do that? For this, it's a very a simple process. So for this we will be drawing one table. like this. So what we will be doing in the first table, we will be writing, say whatever value, say here n is equal to 4. Okay, so we will divide n by 2. Okay, and in this case we will do what? We will be we will write down the quotient here, and then we will write down the remainder here. Okay, so I will simply write down. So next example, so I will just simply write down as q and r and q and r. So so first we have 4. So if I divide this 4 by 2, then just see, I am taking 4, I am dividing it by 2. 2 2s are 4. So remainder is 0. So this is our quotient and this is our remainder. So this is 2 and remainder is 0. We are very fine, okay, with that. Next step is we will bring this thing here. Okay, now we have 2. Okay, now in this case, so in this particular case, n has become 2. Remember that now n has become 2. Now 2 I will divide by, again 2 has to be, so here what happens, it is divided by 2. So 2 divided by 2, 2 1s are 2, so it remains 0. So what we have, this is our quotient and this is our remainder. So we have 1 and then we have remainder is 0. Now you see, we need to keep on repeating this process, till this thing becomes 0. This position has to become 0. Okay, so since this has not yet become 0, we will continue that. Now this thing will come to here. So now we have 1. Now what is the next step? Now our n has changed. So now our n is equal to 2. Sorry, n is equal to 1. Therefore 1 has to divide it by 2. Fine. So you cannot divide 1 by 2. You cannot get a whole number. So it is, so remainder will be 1. So this is a way of, this is not the exact way we should do, but yes, this is way of remembering the things. Okay, so now we have quotient as 0, since this time the number which we are dividing is less than this value. Okay, so the number by which we are dividing is greater than the number which we are actually dividing. So here 1 is less than 2, so quotient is 0 and remainder is 1. Now I clear up all this thing. Now you can see that we have arrived this position has become 0, so we will stop here. Now you can stop here. Okay, now after stopping here, we have got 0 here, we have stopped. Now what we will be doing, we will read this whole thing in a reverse way. Okay, now if I do it in a reverse way, what comes out, sorry, if I read it in a reverse way, 1 0 0. So I have read it in the reverse way. So this is nothing but 4 base 10 in binary system. Okay, so that means what we got, 4 base 10 in binary system is nothing but 1002. So don't read it as 100, it's not 100, it is 100 base 2. So this is one of the examples. Let us try one more. Let us try some double digit. Say I want to convert 45 base 10 to binary. This is our next task. So for that, again, what we will be doing, we will be drawing one table. So this table is a must, and we will be writing n by 2, then quotient, and then remainder. Okay. Now at the first step, we have n equal to 45. Okay, this is our 45. So what I will be doing, I will divide it by 2. So 45 divided by 2, 2 2s are 4, 2 2s are, so 1 remains. So it is, so this is our quotient and this is our remainder. So this is 22 and remainder is 1. Now what is the next step? This thing will come here. Now 22. Now in the next step, (22) is our n. So I will again divide it by 2. So 2 11s are 22. So this time what happened? This is my quotient and this is my remainder. So it is 11 and remainder is 0. Okay. Next step. What is the next step? Next step is this will come here. Now we have 11 here. Okay. Now our n is equal to 11. Now again what happens? We divide it by 2. So 11 divided by 2. 2 5s are 10. Now 1. So that means this is our quotient and this is our remainder. So we have 5 and 1. Okay. Now you can see that this thing hasn't yet become 0. So we cannot stop. We will have to continue. So what is the next step? We will have to, we will have to bring it here. So this is, okay, let me change the color again. So now we have 5 here. Okay. So in this step again our n has changed. Now n is how much? 5. So again I will divide 5 by 2, since in this column what we are doing, we are dividing that value by 2. So 2 2s are 4 and remainder is 1. So this time this is our quotient and this is our remainder. So this is 2, and again let me change the color. So this is, and this is our 1. Now what is the next step? This thing will come here. Now we have 2 here. Now what is our n? N is equal to 2. Now again we need to divide it by n by 2. So so 2 divided by 2, 2 1s are 2, 0. So this is our quotient and this is our remainder. So that's why we have, here we have 2 1s are 2 and here we have 0. Now again you can see that this thing hasn't yet become 0. So we can't stop here. We need to do it further. So how we will be doing? So again I will bring it here. So now we have 1. Okay. And this time again our n has changed. Now this time n is equal to 1. Again 1 has to be divided by 2, because again in this column what we are doing, we are dividing it by 2. So when 1 is divided by 2, since 1 is less than 2 doesn't exactly give a whole number, so we have a 0 here, okay, 0, so 1. So that means we have a quotient and we have a remainder here, okay, and in that way we have 0 and now we have 1. Now you can see that interestingly this has become 0, okay. So that means we can stop here, we can exactly stop here, okay. Now what is the next step? So you can see in this particular table, you can see that we need to read it in the reverse way, okay. So we will be doing it in the reverse way. Let me make it, okay. So we will read it in the reverse way. And then what we get, first is 1, second is 0, third is 1, fourth is 1, fifth is 0, sixth is 1. So what we have, 1 0 1 0 1 1 0 1. So this is the binary form of 45. So we have 45 base 10 is equal to 101101 base 2. So this is the another example. Then I will try to move to the another example, say 1 3-digit number. Let us try 1 3-digit number. Say you have 174 and you are in a base 10 decimal and you need to convert it into the binary. So how to do that? Again the same process I will be following. So I'll make it little zoom in, okay, so zoom out, and then I have this 174, okay, wait. So again we will be drawing the table. So this is our N, this is our Q, this is our R. So first we start with 174. Now this time I will be trying to be little bit faster. So I will need to divide 174 by 2. Okay. So if I divide 174 by 2, I will get, see, 174 divided by 2. 2 8s are 16, 2 7s are 14, 0. So what is that? This is our quotient and this is our remainder, right? So we have, what is the quotient? 87. R is a remainder is a 0. Next step, what is the next step? That this thing will come here and then we have 87. Now what is the next step? We need to divide it by 2. So what I will be doing, I will divide 87 by 2. So 2 4s are 8, 2 3s are 6. So this is our quotient and this is our remainder. So we have 43 and this is our 1. Similarly, next step is this thing will come here. Now we have 43. what is the next step? We need to divide it by 2. Now when you divide it by 2, what happens is 43 divided by 2. 2 2s are 4, 2 1s are 2. So we have this as a quotient and this as a remainder. So we have 21 and then remainder as 1. Next step is we need to bring it here. So it is 21. So what happens if I divide 21 by 2? So 21 by 2, 2 1s are 2, so it is 20. So we have this as a quotient and this as the remainder. So we have 10 and then we have 1. So what is the next step? This will come here. So we have 10. 10 will be now divided by 2. So 10 divided by 2. 2 5s are 10. Remainder is 0. So what is this? Is our quotient and this is our remainder. So this is 5 and this is 0. Next step is this will come here. So we have 5 here. So now what will happen? 5 will be divided by 2. Now when 5 is divided by 2, 2 2s are 4, remainder is 1. So quotient is 2 and remainder is 1. So what we will be writing here? 2 and this is 1. Next step, this will come here. And now the next step is Next step is 2 will be divided by 2. So when 2 is divided by 2, 2 1s are 2, remainder is how much? 0. So in this case, 1 is the quotient and 0 is the remainder. So this is 1 and 0 is the remainder. Now what is the next step? This will come here. So what do we have? 1. Now 1 will be divided by 2. So if you divide 1 by 2, already I have repeated. So this is our quotient and this is our remainder. So it is 0 and this is 1. So you can see that in this particular case this has become 0, so we can stop. Now next step is we need to read this whole thing in the reverse order. So we need to read this whole thing in the reverse order. So for that I need to go to another page. So let us read these pages in the reverse order. So first is 1. So first will be our 1. Second is 0. Third is 1. Fourth is 0. Fifth 1. Sixth 1. Seventh 1. And then we have 0. So this is what we have in the binary. Okay, so this is 174, the base 10. So this is all about conversion of let me go back to our title, conversion of how we convert decimals to decimal numbers to binary numbers. So this is when you interact with a computer and you need to convert your decimal numbers to a binary number, which is basically understood by the computer. In the next video I will discuss how to convert binary to decimal.